And we have a panel of experts. I would like to call upon Dr. Darrell Kleiss from EMC to occupy the chair. Darrell? Yeah, it's just. Darrell is from EMC. He's leading the DA efforts at Environmental Modeling Center. And I'd like to call upon Dr. Sergey Frolov from the PSL, Physical Science Laboratory. And so the reanalysis and data assimilation at the PSL, and he's a DA and couple model forecasting expert. So for detailed bio, I think everybody can go into the UIFCW. And I would like to invite Tom Molinier as a JCSDA director, who has responsibilities of, JCSDA, first of all, is a multi-agency partnership between NOAA, NASA, US Navy, and the US Air Force. He is responsible for the mission to accelerate and improve the data assimilation. And I would like to invite Maui Hong, who is the EPIC program manager. So she has been with EPIC since 2020, and she's leading the effort of the EPIC program and also giving oversight to the EPIC contract. And I would like to invite Henrik from EMC. Henrik, okay. From the OSTI, and he's the UFS, science advisor. I would like to invite Neil Jacobs to the podium. Neil is the UFS science advisor. So just before I start, this panel will actually, and there's one more panel on the Shugang Wang. She's the professor at the University of Oklahoma. She's actually leading the DA efforts there and also actively collaborating with the Environmental Modeling Center and all the operational, contributing to the operations. So in this discussion, one of the leading questions is, we would like to define the rules, the roles, responsibilities, and resourcing to delineate the community efforts for enhancing the UFSDA system, particularly focusing on the JEDI and the enhancements to the DA from the JEDI contribution. So first, Darrell will talk about the history of community DA for NOAA, and particularly the contributions from DTC, GSI, CR, relevant DA, and O2O, R2O efforts. So each panel member will spend about 5 minutes, and then we will have a question and answer session for about 15 minutes. So Darrell.
Great. Thank you very much for the introduction. We have a big panel, so I hope I don't speak for 5 minutes, and I'll try to keep true to form so we have time for Q&A. So I've been at, it's on, can you hear me? I'll swallow the mic, I guess, when I talk, that's fine. So I was thinking about what I wanted to say, and I had a little bit of reflection that next month I'll have been at or affiliated with EMC for over 2 decades, the most of which I have spent engaged in and contributing to community data assimilation, largely through the GSI. So for those that know, GSI was stood up as it started really the collaboration between EMC and GMAO, eventually sort of leveraging the Developmental Testbed Center to then build out a community with support, test casing, documentation, the whole thing. And I just want to use it as a little bit of both a success story, but also a cautionary tale. So we have to think through these things very carefully, because while broadly developing users is a great idea, it's a great way to entrain people to to what we do and give access to the types of problems we care about. But we also have to pay attention to building developers. And while we've had really successful collaborations with the community on certain aspects of data assimilation, the hybrid data assimilation that we implemented over a decade ago in partnership with the OER labs, Jeff Whitaker in particular, and Xu Guang at OU, didn't come about because GSI was a community model. It's a little more organic. And it's really important that you connect people doing this work to the development teams and process. The entire system is interconnected. And having a public release for someone to go play around with in a sandbox is not the most efficient way necessarily to guarantee something coming back that we can implement. So from an operational center, I care deeply about this, and I think we need to really put some thought into how we want to engage and the infrastructure we set up to enable both access to the things we're doing, but also to ensure that we have operational outcomes and to influence and improve the systems that we all care about. DA is messy, it's complicated, it's fundamentally connected to the models and the applications we use. Observations are even more messy. If any of you have seen the workflow diagrams from Curtis and Jacob, you'll see how complicated these things can be. These are not particularly penetrable for the research community, so we really need to pay attention to what I call the four-letter word workflow and the support we put around it, because this stuff is hard. So the last thing I want to say, EMC my team spent some time drafting a 10-year strategy, and we're really thinking about where we want to go in the future, and one of the pillars, of course, is embracing our next generation data assimilation infrastructure. JEDI is the centerpiece of everything we want to do over the next decade. And it's not just JEDI, it's also relying on partnerships. So using our next generation infrastructure to engage with key partners, both in government, in industry, in academia, to realize the innovation that we need to execute over the next decade. So with that, I'm going to pass it off to OER, and hopefully we have time for questions at the end, because I'm really curious to engage with the audience and see what people think about this problem. Thank you.
Thank you, Daryl. So I'll try to provide OER perspective, and if there is contributions from the room from people who've been at OER longer, I'll be happy to engage that. My perspective is that one way to introduce OER is to contrast it with university, not with JCSDA, but with university, with what Xu Guang will be talking about later, and EMC. So OER is a full-scale research lab, or network of labs, right? So we go from conceptual models all the way to pre-transition implementations. And Xu Guang's work, for example, demonstrated the same thing is possible doing in universities. But because the structure of incentives, resources is different at OER, we tend to focus on working specifically on the problems relevant to our partners at EMC, at operational centers, and carrying that fundamental ideas of research to something that can be used in operations. And the way we're supported was not as responsive to proposal calls as universities do. And we also have access to pre-operational platforms, so we can work closely with EMC, much closer than the university community can. One thing that I think OER doesn't do, and I think it's appropriate, is actually take it all the way to transition to operations. And I think that's where the EMC comes in. And I guess that probably is a good introduction to where OER fits into this picture.
So, Tom, yeah.
All right. Hi, everybody. My name is Tom Molinier. So I work for the Joint Center for Satellite Data Assimilation, the JCSDA. And just a quick explanation of what it is that collaboration between NOAA, NASA, Air Force, and Navy. And within NOAA, there's a National Weather Service, and there's also NESDIS. And we've been at developing JEDI, so we're spearheading the development of the JEDI. And I want to emphasize how important that effort is and how much is really a quiet revolution for our community, because we have now, all the major agencies doing data assimilation, adopting a common data simulation for their Earth system components, for their Earth system models in the future. And this is actually, the next generation data simulation for the nation. And it goes even, beyond with the Met Office and partners adopting this as well. This is a unique opportunity to bridge between research and operations, and this is really going to bring us to new levels in terms of scientific exploration, in terms of agility to look at problems, complex problems that we didn't have the capability to do before, and also to scale in terms of a community to very, very complex Earth system data simulation. As Daryl was mentioning, data simulation is extremely complex and messy, but we're building actually infrastructure for a complex ecosystem of developers that are ranging from academia to private sector to government agencies to collaborate and work efficiently together. So our goals are basically, first and foremost, transition that revolution into operations, a series of operational systems in our partner agencies. Then phase two is to actually use that new flexibility to convert on new innovation and rapidly transfer that new innovation to improving the skills. And the third goal is to use this to actually train the next workforce and actually engage a broad research and academic community into using that system to really explore new ideas and bring that innovation into the funnel. So I invite you to get more information from the DA and then JCSDA channels like a newsletter, website, recordings of previous science workshops, and I'll pass over to the next speaker and leave some time for questions.
Maui, could you give us
Okay, thank you. I'll keep my comment very short. As Dorsey just mentioned, the DA consortium will be coordinated by the EPIC program. I first of all want to thank my director, Dorsey Koch, and the deputy director, Jonathan Hoff, as well as Krishna, and to spend a lot of time to make sure that the DA consortium NOFO is drafted and posted. And I want to get back to that NOFO a little bit. If you read the NOFO language, what it says there is that there are two recommendations from the power report. One is that DA is really a very critical element in numerical weather prediction models. And if we really want to catch up with the leading world centers in this area, DA is the area we need to focus on. So that's one thing from the power report. The second thing is that there is a critical shortage of workforce out there for any of us to recruit. So part of the motivation to have a multi-university consortium is actually to train that next generation workforce. And then there is also a call for collaboration with other countries, agencies, to not only advance DA as is, but also think about the next generation technology, including AI and machine learning. So I encourage you to look into the NOFO language carefully before you apply. At the program office level, we are thinking about to provide a webinar when at a later time we will announce that. So that's pretty much what I want to say.
Henrik?
Okay, I'll agree with a lot of the things I've heard so far. I want to add three different aspects to what data simulation is doing. Number one, if you look in operations, we always talk about data simulation, but we use it in different ways. We use this for model initialization, which is usually what we're talking about, but we also use it for product generation. And there are very different requirements for these two, because very often the product generation is about the best possible state that you can do for either forecasting or validation later, But for models, it's the best initialization of the model, taking care of the best forecast after that. So be aware of that. There's two different things. And then in between, there is the merging of data into a single product. All these things have their different needs. Second thing is that we have to realize why we do data assimilation. And it's kind of funny that I'm sitting here. I had a 25-year career in doing wave modeling, and I did it just absolutely fine without any data assimilation ever. And yeah, we're doing data assimilation because the atmosphere and the ocean are chaotic initial value problems. And so you have to have the best possible initial state to be able to do a forecast. And there's no other way to do that than to observe and to use your observations. A wave model is a strongly forced and damped system. And as long as your forcing is okay, it doesn't really matter what your initialization is, you'll go to the proper answer. Ice and land are a little bit in between. They tend to be more forced and damped, but they tend to be having some bifurcation points in solutions. But so we lived in a world that data assimilation was really mostly important just for the atmosphere part of the UFS and the ocean part. That world is changing. We're looking at coupled modeling now. We're looking at coupled DA. And now suddenly, if I go back to my old stomping grounds, go back to looking at the wave interface, the atmospheric boundary layer, the mixed layer of the ocean, there is all kinds of information contents across the interface. And an observation of the ocean can improve my behavior of the atmosphere. And we've seen some examples of that earlier this week and last week at the Weather and Forecasting Conference. Then last but not least, just as a historical perspective, it is fun to see people like Tom really taking the lead on doing this as a community approach, as a good, well-engineered system approach. I want to remember that the first real community modeling I've actually seen in the Weather Service and where I learned how to do community modeling is from the late and great Paul van Delst, who was running the CRTM originally. And I would like to recognize the fact that he's passed away almost 10 years ago, but that he really was the first person who taught people at EMC from a part of the data assimilation side how to do community modeling. Thank you.
Neil?
I just wanted to hit on a couple of things in no particular order, but I did want to start off with the workforce issue. That's a huge problem. I can tell you from my time at NOAA, having access to people to get security clearances who weren't necessarily foreign nationals is a huge challenge. Before I was at NOAA, I was at Panasonic, and we started running the GFS there with the GSI. We literally had to recruit people out of retirement to come work on the system because we couldn't find anybody. From the UFS perspective, I know that there's a lot of interest in pushing this code out to the community, but there's spin up in the community. They're going to have to learn how to use it. They're going to have to understand it. I don't know that it would be the best use of our time or their time to get them trained and spun up on a system that we know we're going to be sunsetting soon. So I'm all for waiting for JEDI to go out and getting the community working on that versus getting them going on GSI if JEDI is really, if we're all in on that. There's another interesting thing about this that maybe this is science fiction, maybe this is pie in the sky, maybe I'm being a little bit naive or optimistic, but I think it would be super cool if we had the capability to run the DA system in the cloud, which I know we can do, but do FSOIs and OSCs in parallel. And the reason why it's interesting in the cloud is you basically can do as many parallel runs as you want. And that's a luxury that you don't have with on-prem compute. And why I think that's going to be critical going forward is I think in the next 5 to 10 years, you're going to see a proliferation of commercial observations come online. And NOAA doesn't have the bandwidth to do impact studies for all these different commercial observation providers. Nor do I think it's their responsibility if these commercial ob providers are going to be making money selling the data to NOAA. I think it's on them to test the impact of their own system, but it's got to be done in an open, fair, transparent way. And the cloud sandbox really lends itself to those kind of tests where everyone can see what the impact is. But in order to pull that off, you kind of need the full complement of all the existing observations that go into the model. Otherwise, you're going to inflate the impact of whatever they put in there. And to that point, NOAA's working on what used to be called the Big Data Project. It's now the NOAA Open Data Dissemination, or NOD, which is awesome, but there are a few caveats and challenges. And one of them is egress. You put all that stuff there, it's going to cost you a lot of money to download it or move it around. And that includes moving it from one cloud service provider to another cloud service provider. So when we're thinking about running a lot of these impact studies and all these systems in the cloud, to the extent that we can mirror both the observations and the DA systems in multiple cloud service providers, just to avoid having to move data around and pay for that. The last thing I wanted to mention was the education aspect. So this is how we sort of tackle the workforce recruitment. We need to train students coming out of school to do this. There's not a lot of universities that teach a DA class, and if they do, it's usually a theory-based class. There are not a lot of hands-on DA classes running code, and I think JEDI EDU, and I hope Tom has an opportunity to talk more about this, is a really, really cool idea. Because if there was a class out there or two that was teaching DA by actual doing, running the code, it was usually something like WRF DA, or that particular university had their own Linux cluster. That you don't see that. There's not a lot of universities that have those opportunities, but to have something like JEDI EDU where you can do some simplified toy model type DA experiments as a teaching tool on a laptop is a really cool thing to use, especially if you're developing a class for undergrads or even grad students. So hopefully we get a chance to talk a little bit more about that.
Thank you, Neil. I think we would like to hear the academic perspectives from Xiugang. So you have slides, Xiugang, should I? Yeah.
Okay. All right. Thank you for including me as part of the discussion on the community data simulation development. So I'll offer perspectives from the university academia side. Next slide, please. So to really advance data simulation, we have to address a lot of grand challenges. Actually, they were all mentioned by several panel members already. So data simulation is trying to combine model with observations. The problem is that we're having very high dimension model and a lot of observations. Combining this two is going to create a lot of scientific and technical challenges. The next generation NWP will be using a Earth system modeling approach. This means we need the data simulation to initialize multiple Earth system components, which represent different scales. And not only that, we need to initialize their interactions properly, so-called coupling. Multi-scale data simulation not only applies for couple DA, but also for individual Earth system component like atmosphere, which houses many, many scales. If you want to predict the storm correctly, we need to initialize the storm itself, but also its larger scale environment. Model error. If we have large model bias, or if we're not able to sample model errors in data simulation, no matter if you're using ENCAP, ENVAR, or other non-Gaussian filters, you're correcting in the wrong space. So we have to deal with model errors in data simulation as well. So observation side, in order to combine observation with model, we need to know very well the observation error characteristics, errors, also to build the operator to connect the observed quantity with the model variables. So really, for this grand challenge over here, no single person or entity can do it at all. We really need to have collaborations effectively. One of the backbones for data simulation advancement is innovation. We really want to have constant new ideas, put in place to address all these challenges on the left. This is actually naturally integrated with the O2R, R2O process. For example, our new ideas may be driven, motivated by the issues we're seeing from operations. And our new ideas, in the same time, if selected through R2O, can be constantly tested, validated through the daily forecast. So that's a very natural integrated process. Last but not least, I think this has been mentioned by many panel members already, the workforce. So we all understand in the end, it's the people who is going to do all this data assimilation development and research. So we really have to put in place a long-term strategic plan to foster the growth of workforce in data assimilation. Next, please. So I was asked by Daryl to talk about the roles of academia can play for data assimilation advancement. So first, university can contribute data assimilation advancements through performing data assimilation research at relatively high levels, like level 5 and 6 maybe, and above, but we also can contribute for relatively low-level research. So I just list a few ideas here that we can contribute. For example, multi-scale data assimilation, for coupled data assimilation, for individual Earth system component BA, use like artificial intelligence, AI, machine learning within data assimilation, methodology to represent reduced model errors and bias in data assimilation, methods to estimate observation error and biases, and cost-effective and accurate observation operators, methods to guide observation network design and the evaluation of observation impact, efficient data assimilation algorithms, and methodology to treat non-Gaussianity, for example. Next, please. So as mentioned by many members, data assimilation is really challenging, messy, because it's, in my opinion, transdisciplinary in nature. So on the left is the diagram I normally show on the day 1 of my data assimilation class I'm teaching at Oklahoma. So what it takes to become a data assimilation scientist, it needs deep mathematical understanding, physical process understanding of observations you're assimilating, understanding of the model you're using, and understanding of data science. So acquiring all skills, this is not going to happen overnight, over a week, over months. Normally it takes students years to actually got all the skills needed to become a DA scientist. So to really have a sustained DA innovation, we really need to have a sustained support for DA workforce development, as mentioned, highlighted by many members already. Next, please. So I think Dorothy also mentioned this during her opening announcement. Back in 2021, NOAA published this power report. I had the pleasure to contribute this report developed by co-leading the observation data assimilation task team. So in the report, it identifies a serious gap in the workforce expertise in data assimilation. So so the university is well positioned to help fill these gaps. And as I said, acquiring all the skills is not going to happen in a short time. So basically, the university can help students to acquire those skills through their graduate studies by teaching data assimilation class, by allowing them opportunities to research on data assimilation through their thesis and dissertations. So there's really need a long-term strategic partnership between university faculty, specialized in data assimilation and NOAA, to advance both data assimilation research and education. So to me, it's very exciting that Dorothy made this official announcement about a DA consortium. I think that's going to be a big leap forward to help us address both the workforce issue and the data assimilation research advancement. That's a great idea. That's actually a very, very exciting announcement that I just heard. Next, please. So actually, yesterday I mentioned there are many, many great features in JEDI publicly released already, which we have been using to do the migration and to start research. I'm just re-showing this wish list from that I collected from students. And I think in addition to research, supporting research, if we can use the community model, the data assimilation system in our classroom teaching, like JEDI ADU idea, that'll be fantastic too. And if the community model can actually allow us to contribute back to the research development, back to the system, so other people can use it and the operational center can also use it, that'll be fantastic too. It's nice to hear Tom already have this ideas, put in place as part of a JEDI development. Last slide. So I just want you see this one more time, the support needed. So as everybody's moving toward using JEDI, I think we need actually extend support to address, answer various questions from beginners, new users, and also developers. I think that's all for me.
Thank you, Shugang. I think having heard all the perspectives, I would like to just mention about the success stories that Daryl alluded to about the GSI and the community efforts, and also on the community ready to transfer model development. So one of the central questions, I think, Dorothy's announcement in the DA consortium is, how do we really foster DA collaboration with the wider UFS community with the JEDI framework? So that's one of the questions that we have. So we have about 15 minutes, so I think we would like to open up the questions from the audience. So yeah, please line up in both of the lines.
Hey, Krishna, we have an online question.
Yes, okay.
Does the panel have any suggestions on how EMC, OAR, and others should replace GSI with JEDI and adopt new DA science? Should EPIC play a larger role in that?
Molly.
All right, so unfortunately, we just had discussion yesterday in the evening to talk about how EMC, JCSDA, EPIC, and OAR labs can better coordinate in terms of clarifying the R2O and O2R funnel. Because right now, if I understand it correctly, JEDI has a mission of serving all agencies that you need to coordinate, and any JEDI development will not be specifically targeted for UFS. While we can support research configurations, we have an operational target to provide the next generation forecast system that can be operational at NOAA. So EMC really need to focus on that mission critical tasks. And so what EPIC can fill in between is to provide developer support to clarify the higher readiness level steps, establish the stages and gates to make sure that any generic JEDI development can be customized for UFS and provide that, release that to the community, as well as to coordinate with EMC to make sure that that can be implemented into future operational configurations. That's my understanding. I might miss something, so I'll pass that along to Daryl and Tom to comment.
So the first thing I'll say is that the most common question I get, which kind of drives me crazy, is when will JEDI be ready for X? And the answer to that question is, it will be ready and become ready when people contribute to help make it ready. This notion that the core staff is busy building an application that they don't even know about is just going to happen out of the kindness of their heart or some sort of magic thinking is not the right way to think about this. So EPIC absolutely can and should play a role to help facilitate contributions so that we as a community can get JEDI ready, not just for operations, but we're already ready to start contributing research. We're putting stuff into JEDI now that we have never used operationally, that we may want to use operationally in the future. So it's not just the operational transition, it's also focusing on making contributions to things we want down the pike and things to set up for success over the next decade.
Tom, would you like to comment on?
I'll be short because I think Daryl has actually made a really good point. Is JEDI ready today for the community to look into it? Yes. Is it ready for the community to start to develop into it? Yes. Is it ready for new contributions? Yes. So basically, I invite anyone who's curious, who's interested, who wants to do new and exciting science to dive in. And I realize it's a leap because it's a very new system. But as I was saying earlier, with that quiet revolution, it's also, it's the first time in a generation that we have all the major actors that are all converging into a common software stack for a very complex system. So that really opens huge opportunities for a nation.
We'll take a question from the audience. Yeah.
Yeah, this is really a question probably for Tom and Daryl. I know you've both given some thoughts to data assimilation in space weather applications, because space weather modeling, especially in the whole atmosphere model, it's a very different dynamical system. And currently we just don't have DA above 60 kilometers. Just wonder if you could say a few words about if you can see the JEDI being expanded to include this very dynamical system for the space weather applications.
I'll start, and because the answer is absolutely. It's only it was basically a question of both timing and resources, and both are getting now ready, so aligned. So we started with the NWP, aerosols, trace gases, land, snow, ocean, sea ice. So we figured maybe space weather can wait a little bit because it was already quite a big effort. But now actually there's, the priority is there. There's actually a big ask from our partners, not just NOAA, but also DOD and NASA. And there's actually resources are starting to align. So that's really coming up. So the nice thing is catching up on everything that's been done will be actually really made easy by the generic nature of JEDI. So we can expect really to go fast in terms of development. Exciting.
So I think rather than focusing on the space weather part of the question, I would point to the examples of us building sort of DA systems for other, I'm a meteorologist by training. I don't spend any time thinking about tropospheric weather anymore. I spend all my time thinking about all the other stuff connected to it in coupled DA. So we have an aerosol system based on JEDI. We're doing snow assimilation based on JEDI. We have a mature ocean system and sea ice system strongly coupled based on JEDI. So these things were much easier to do in this infrastructure, and that's by design. We're already starting to see the fruits of the labor. So extensions to new applications, actually get it in the plumbing and let's get to work.
Yeah, and just to add to that, that was actually by design. What Daryl just said, we knew that we were going to have to completely rebuild all the data assimilation that we needed to do. And so you look at risk mitigation. And so we specifically chose at EMC to first do things like an ocean data assimilation and some other ones, because the risk of that failing would be much smaller. And the opportunity of actually showing the success would be a natural step to go to the much bigger system. And so in that same context, there are opportunities to do the smaller things first. And so it's a question of just aligning your resources and the people who are interested in that with doing that.
So could we take one question?
Krishna, we have about 5 minutes left.
Yeah. Okay. Wendy, go ahead, and then I'll go back to.
Hi. So I've been thinking about the workforce development thing, and I'm really excited to hear about the DA consortium opportunity, but obviously that's not, a fix for tomorrow, and a lot of us are trying to hire right now. And I'm wondering if there should be more of a sort of a community-wide effort towards not just, training DA experts coming up, but trying to hire people, and then thoughts are on that, whether that's a worthwhile avenue.
I completely agree. I think a lot of the people that are well suited for DA are probably in other departments like math and physics and software engineering, and maybe have no idea about NWP at all. And so one of the things that I want to do with the UFS with the comms and outreach is not just reach out to other atmospheric science departments, but those other departments which might have those students that are looking to go into something interesting. Because if you understand logic and can write code, why not come over and work on DA?
Just, I think your point is an excellent point, and in DA are coming from astrophysics background, computer fluid dynamics background, completely different backgrounds that that we bring in and we train them on a job basically. So it is happening, and it basically we have no choice. We want to bring the best talents.
We'll take one more question.
So, in your opening remarks, Daryl, you mentioned the challenge around workflow and how it's, almost, to the best of my knowledge, the workflow tools associated with JEDI are not part of what's publicly available. Given the challenges around workflow, can we expect to see those relatively soon so that people who are working on the workflow can do that work with reference to those tools?
I hate to speak too much for it, but yes, that's something actually we just discussed yesterday in the meeting that Maui mentioned. That is expected to be released to the community. We're really thinking of experiment as a service, so really bringing a service to the community to actually run science experiments, almost like press button. So the workflow and not just the workflow, all the data pipelines, all the diagnostics, all the entire end-to-end ecosystem to do science is something we want to release to the community.
Darren, would you like to add questions?
I'll add to my perspective on the workflow. So as a OER lab, we sit between EMC and JCSDA in many ways. Literally. And the way I look at workflows right now is that they all serve different purposes. And a lot of times I think it's appropriate to work with EMC's workflow because it's really targeted towards transition to operation. While I can see that OER labs and people outside of OER might want to spend some time working with Skylab flow to do fast prototyping of innovations. So to answer Ben's question, I think we're going to a place where there will be different solutions for different problems. So that's what I see emerging in the next couple of years.
I think, we need to understand and establish clear priorities for R2O and O2R. So that is one important thing, I think, with one of the priorities articulated in the DA consortium is also that, how do we really communicate that O2R and R2O priorities at varying levels, because people have, the users and the wider community is from at all different levels. So that's again important. So I would like to thank all the panelists for an exciting and illuminating discussion on DA and the future direction. And I would like to thank Dr. Shugang from university on giving all the academic perspectives. The wish list, I think we want to sort it out in the future. So I would like to thank the audience and all the questions on this. Thank you so much.